The world of technology is on the brink of a revolution, one that promises to redefine the limits of computation, problem solving, and innovation. This revolution is not driven by faster processors or larger storage devices, but by an entirely new paradigm of computing, quantum computing. Unlike classical computers, which rely on bits to process information, quantum computers use quantum bits, or qubits, to perform calculations at speeds that were once thought impossible. Welcome to Primal Geek, the channel where we dive deep into the world of technology, innovation, and the future. Today we're exploring the fascinating world of quantum computing, how it works, why it's so powerful, and how it could transform industries. If you love tech and want to stay ahead of the curve, make sure to smash that like button and subscribe to Primal Geek for more deep dives into the most exciting advancements in technology. What is quantum computing? To understand quantum computing, we first need to understand the basics of classical computing. Classical computers, like the one you're using to watch this video, process information in binary form. They use bits, which can be either a 0 or a 1, to perform calculations. Every app, website, and game you use is essentially a series of zeros and ones being processed by a classical computer. Quantum computing, on the other hand, operates on an entirely different principle. Instead of bits, quantum computers use qubits. Qubits can exist in a state of 0, 1, or both simultaneously, thanks to a quantum phenomenon called superposition. This means that a quantum computer can process a vast number of possibilities at once, making it exponentially more powerful than classical computers for certain tasks. But superposition is just one piece of the puzzle. Another key concept in quantum computing is entanglement. When qubits become entangled, the state of one qubit is directly related to the state of another, no matter how far apart they are. This allows quantum computers to perform complex calculations with incredible efficiency. Finally, there's quantum interference, which is used to amplify correct solutions and cancel out incorrect ones. Together, these principles enable quantum computers to solve problems that are currently beyond the reach of classical computers. How does a quantum computer work? At its core, a quantum computer is a highly specialized machine designed to manipulate qubits. But how exactly does it do this? Let's break it down. First, qubits need to be created and maintained in a stable quantum state. This is no easy task, as qubits are extremely sensitive to their environment. Even the slightest disturbance, such as temperature fluctuations or electromagnetic waves, can cause qubits to lose their quantum properties, a phenomenon known as decoherence. To prevent this, quantum computers are often housed in highly controlled environments, such as supercooled refrigerators, to isolate the qubits from external interference. Once the qubits are stable, they can be manipulated using quantum gates. These gates are the quantum equivalent of classical logic gates, but they operate on the principles of quantum mechanics. For example, a quantum gate might flip the state of a qubit from 0 to 1, or put it into a superposition of both states. The real power of quantum computing comes from the ability to perform operations on multiple qubits simultaneously. For instance, a quantum computer with just 50 qubits can represent over a quadrillion possible states at once. This parallelism allows quantum computers to tackle problems that would take classical computers millions of years to solve. The potential of quantum computing. The potential applications of quantum computing are vast and far-reaching. Let's explore some of the most exciting possibilities. Number 1. Drug discovery and healthcare. One of the most promising applications of quantum computing is in the field of drug discovery. Developing new drugs is a time-consuming and expensive process, often taking over a decade and costing billions of dollars. Quantum computers could revolutionize this process by simulating molecular interactions at an unprecedented level of detail. This would allow researchers to identify potential drug candidates faster and more accurately, potentially leading to breakthroughs in treating diseases like cancer, Alzheimer's, and COVID-19. Number 2. Cryptography and cybersecurity. Quantum computing also has the potential to disrupt the field of cryptography. Many of the encryption methods used today, such as RSA, rely on the difficulty of factoring large numbers, a task that classical computers struggle with. Quantum computers, however, could solve these problems in a matter of seconds using algorithms like Shor's algorithm. While this poses a threat to current encryption methods, it also opens the door to new forms of quantum-resistant cryptography that could make our digital world even more secure. Number 3. Optimization problems. From logistics to finance, many industries rely on solving complex optimization problems. For example, airlines need to optimize flight schedules, while financial institutions need to optimize investment portfolios. Classical computers can handle these problems to a certain extent, but they often struggle with the sheer complexity involved. Quantum computers, with their ability to process multiple possibilities simultaneously, could provide solutions that are far more efficient and cost-effective. Number 4. Climate modeling and environmental science. Climate change is one of the most pressing challenges of our time, and understanding its complexities requires massive amounts of data and computational power. Quantum computers could enhance climate modeling by simulating atmospheric and oceanic systems with incredible precision. This could lead to more accurate predictions and better informed policies to combat climate change. Number 5. Artificial intelligence and machine learning. Quantum computing could also supercharge artificial intelligence and machine learning. Many AI algorithms involve processing vast amounts of data and performing complex calculations. Quantum computers could accelerate these processes, enabling more advanced AI systems that can learn faster and make better decisions. Challenges and limitations. While the potential of quantum computing is immense, there are significant challenges that need to be overcome before it becomes a mainstream technology. Number 1. Technical challenges. Building and maintaining a quantum computer is no small feat. Qubits are extremely fragile and require highly controlled environments to function properly. Additionally, quantum computers are prone to errors due to decoherence and other quantum phenomena. Researchers are working on error-correcting codes and more stable qubit designs, but these solutions are still in their early stages. Number 2. Scalability. Another major challenge is scalability. While quantum computers with a few dozen qubits have been built, creating a machine with hundreds or thousands of qubits is a daunting task. Each additional qubit increases the complexity of the system, making it harder to maintain stability and reduce errors. Number 3. Cost. Quantum computing is an expensive endeavor. The infrastructure required to build and operate a quantum computer, including supercooled refrigerators and specialized materials, comes with a hefty price tag. As a result, quantum computing is currently accessible only to well-funded organizations like governments, tech giants, and research institutions. Number 4. Ethical and societal implications. Like any powerful technology, quantum computing raises ethical and societal questions. For example, the ability to break current encryption methods could have serious implications for privacy and security. Additionally, the widespread adoption of quantum computing could disrupt industries and lead to job displacement. It's crucial that we address these issues proactively to ensure that the benefits of quantum computing are shared equitably. The future of quantum computing. Despite the challenges, the future of quantum computing looks incredibly promising. Governments, tech companies, and research institutions around the world are investing heavily in quantum research and development. Companies like IBM, Google, and Microsoft are racing to build more powerful quantum computers, while startups are exploring innovative applications of the technology. In the coming years, we can expect to see quantum computers solving real-world problems that were once thought to be unsolvable. From discovering new drugs to optimizing global supply chains, the possibilities are endless. However, it's important to remember that quantum computing is still in its infancy. It will likely take decades before the technology reaches its full potential. Quantum computing represents a seismic shift in the world of technology. By harnessing the strange and counterintuitive principles of quantum mechanics, quantum computers have the potential to solve problems that are currently beyond the reach of classical computers. From healthcare to cybersecurity, the applications of quantum computing are vast and transformative. So, what do you think about quantum computing? Are you excited about the possibilities, or do you have concerns about its implications? Thank you for watching Primal Geek. If you enjoyed this video, don't forget to smash that like button, subscribe, and hit the notification bell so you never miss out on our latest explorations into the world of technology and innovation. Let us know in the comments which emerging technology you're most excited about. Until next time, stay curious and keep geeking out.